discuss about probability. One short question for Tom 2. Conditional probability. What is conditional probability? The conditional probability of E, given that F has already occurred, that is equal to probability E condition of F, which is equal to probability E intersection F by probability F, provided a probability of F is not equal to 0. So the conditional probability of E, given that F has already occurred, given that happened, occurred, past participle case is given in condition concept. So then you have to apply condition probability. Now, similarly, probability of F condition of E, that is equal to probability F intersection E by probability of E. Now take one example. Suppose probability of A given, that is the 9 by 17, and probability B is given, that is the 7 by 17, and probability A intersection B is given 4 by 17. Now, probability A condition of B is equal to probability A intersection B by probability of B. It means simple 4 by 17 divided by 7 by 17. 17 cut, it goes to 4 by 7. So similarly, probability of B condition of A, that means probability of A intersection B by probability of A. Now, what are the different properties related with the conditional probability? So the property also come in 2-mark question. So here conditional probability is a very much important in Term 2, because in probability section, that is a 9-mark question will come. 9 mark means case study 2 and 2 do 2 marks question, and another, that is the 2 marks and 3 mark, total, that is the 5-mark question will come in Term 2 exam. So now we'll discuss the property of conditional probability. Properties of a conditional probability. Number 1, probability of a sample space condition the event is equal to 1. Probability of event F condition F is equal to 1, where S is a sample space and F is the event. Now proof. Probability of S condition of F is equal to probability S intersection S by probability of F, which is equal to probability F by probability F, because F is a subset of a sample space, means F, this is every element of F is in sample space S. So that's why F is a subset of S. So F got, then it comes to 1. It comes to 1. Similarly, probability F condition of F, that is equal to probability F intersection F by probability F. That means probability F by probability F is equal to 1. Similarly, property number 2, probability of A union B, condition F is equal to probability of A condition of F plus probability B condition of F minus probability A intersection B condition of F. Now here A and B and F are non-empty events of sample space S. Now proof: probability of A union B, condition of F is equal to probability A union B intersection F divided by probability of F divided by probability of F. So by distributed property, that equal to probability of A plus probability of B. Here probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, you know. So this equal to probability A union B condition of F, that is equal to probability of A union B intersection F by probability of F. It means by distribution law, A intersection F union B intersection F whole divided by probability of F. That means probability of A intersection F plus probability B intersection F minus probability A intersection F intersection B intersection F whole divided by probability of F. Here you can say this is equal to A, this is equal to B, means A union B. What new about A union B? Probability A union B is equal to probability of A plus probability of B minus probability A intersection B. So that's why probability A intersection F by probability F plus probability B intersection F by probability of F minus probability of A intersection B intersection F. Now taking bracket whole divided by probability of F. It means here F are 2. By taking intersection concept, if 2 are same, you can take 1. So that's why A intersection B intersection F. That by taking the bracket, A intersection B intersection F by probability of F. That means, so what value comes? Probability of A union B condition F is equal to probability of A condition F plus probability of B condition F minus probability A intersection B condition of F, it comes to. Now you can take another property, that is complementary property. Third property, probability of E dash condition of F is equal to probability of E 1 minus probability of E condition of F. So, probability of S condition of F, that is equal to 1. Probability of E union E dash condition of F is equal to 1 because E is an event, E dash is also event. That is equal to sample space. Means here you can say, suppose this is E and this shaded region is E, that is E dash. So that E and E dash, the union comes to sample space. So put it in the place of sample space now. So probability of E condition of F plus probability E dash condition of F is equal to 1 because E intersection E dash is equal to I. So probability E intersection E dash is equal to 0. Now here probability of A union B condition of A is equal to probability of A condition of A, probability B condition of A minus probability A intersection B condition of A. Now here probability E complement condition of F is equal to 1 minus, this comes to this side, 1 minus probability E condition of F. Now third property verified or proved. Now comes to very important question in conditional probability. What is question here? Now family has 2 children. What is the probability that both the children are boys, given that at least one of them is a boy? Given that concept is there, so that's why you can say that is a conditional probability. Now, from that concept, you have to find a probability both children are boys. This is an event. Now, from the question, you can take that is event. Event means both the children are boys, one event. Another F is the event, that is at least one of them is a boy. At least one of them is a boy. Now, what is the sample space? It may be boy boy, it may be boy girl, it may be girl boy, it may be girl girl. Then both the children are boy, it is only boy boy. And at least one of them is a boy, it means boy girl, girl boy, and boy boy. Here, at least one of them boy means either one boy or two boys. Now, according to the question, what is the probability that both the children are boys given that at least one of them is a boy? That means probability of E condition of F. That means probability of E intersection F by probability of F. Now, what is the probability of F? That is equal to 3 by total 4. See? Probability of F means number of events, F, number of element of the event F, and the number of element present in sample space. So, element present in F divided by element present in sample space is equal to probability of F. That is 3 by. Similarly, probability of E intersection F. E intersection F is equal to simple BB. Probability E intersection F is equal to, that is in 1 by 4. Now you put it here, E intersection F is equal to 1 by 4 and probability F is equal to 3 by 4. Now 4 got, that is 1 by 3 is the required result. So, according to the question, E condition F means what we need, probability E intersection F by probability F is necessary. So that's why probability F you have to find out and probability E intersection F you have to find out. After that you put it here and get the result. Now take another question in conditional. It is a very important question. Very, very important question. So here, tossing a coin, it may be head, it may be tail. If head comes, toss again a coin. If tail comes, through a die. 1, 2, 3, 4, 5, 6 comes. And what about the sample space now? Head, head tail, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. These are sample space. Then, event given the die shows a number is greater than 4. The die shows a number greater than 4. That is, the number is greater than 4. It means T5 and T6. Now, be the event that is given, that condition is there here, at least one of tail, at least one tail It means head tail. It means tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. Now A intersection B is equal to T5 and T6. Here, probability of A is equal to, that means here T and 5. For T, that probability is 1 by 2. For 5, that is probability is equal to 1 by 6. Then for T, that is probability is 1 by 2. For 6, the probability is 1 by 6. This or this. That means 1 by 2 into 1 by 6 plus 1 by 2 into 1 by 6. It means 2 by 12. Means 1 by 6. Similarly, probability of B is equal to, that is it, HT, H for the probability is 1 by 2. For T, that is equal to 1 by 2 plus, that is it, for T, that is 1 by 2, that is 1 by 6 for 1. 1 by 2, 1 by 6. 1, here T, that is 1 by 2, for 1, that is 1 by 6. T for 1 by 2, 1, that is it. T for 1 by 2, that is it. 3 for 1 by 6. That means T for 1 by 2, T, okay, 4 number for 1 by 6. Similarly here 1, 2, 3, 4, 5, 6. And that these are the same pattern. So that's why you have to multiply with 6. Now it comes to 1 by 4 plus 1 by 2. It means here 1 plus 2 by 4. It means 3 by 4. It means 3 by 4. So here what value comes? It is 2 plus 1 plus 2 by 4 is equal to 3 by 4. Now, probability A gone, probability B also got. Probability A intersection B जो value है, probability of A, that is the same thing, T5, T6, T5, T6. That's why probability of A is equal to probability of A intersection B. Probability A intersection B. Here, probability, find the probability of the event that the die shows a number greater than 4. Means A, here given that a condition, there is at least one tail, means condition B. That means probability A intersection B by probability B. It means that is a 2 by 12 whole divided by 3 by 4. Means 4 it is equal to 3. It means 2 by 9. 2 by 9 is the answer. Now comes to multiplication rule of a probability theorem. Multiplication theorem on probability. We know that probability A condition of a B is equal to probability A intersection B by probability B, provided probability B is not equal to 0. Here probability A intersection B, you goes to this side. It means probability of B first drawn, second drawn, that is A, that condition is B. Similarly, probability B condition of E, A, you know, B intersection A, that is the probability of A. So it comes to probability of B intersection A is equal to probability of B, then probability of A first, probability of B condition of A. Here first draw probability of A, first draw A, and second draw, that is B. After first drawn, A drawn, then if you want to draw B, then A is the condition is there. So these rules are called, multiplication rule, of a probability. Similarly, if more than 2 events given, then what is the multiplication rule? Just like you say, A is event, B is event, C is event. Then A intersection B intersection C is equal to probability of A. Suppose you have to find out first A, then probability of A. Then you want to find out the B, that is A is the condition is here. If C, you can say that is A and B is the condition. Here A intersection B जो value है, A B same value है. So that's why here this is the multiplication theorem on more than 2 events. More than 2 events. Take one question. A bag contains 5 red, 4 black. Now, you draw 2 balls. Two balls are drawn. So, probability of maybe black 1 intersection black 2, or black 1 intersection red 2, or probability of red 1 intersection black 1, sorry, black 2, or probability red 1 intersection red 2. It means first draw, that is the black 1, second draw, that is the black 2. So what is the probability here? Probability of a black 1 into probability of black 2 condition of a black 1 plus probability of black 1, then probability of red 2 condition of a black 1. Then probability of red 1, probability of black 2 condition of a red 1. Now, probability of red 1, probability of red 2 condition of red 1. That is particular multiplication rule of probability. Black 1 means dark black. divided by 9. Next, black 2, that is without repletion concept is here given. So that's why एक कम हो गया, then black also एक कम हो गया. Plus, suppose black 4/9, then red 2 means 5/8. Similarly, red 1, that is 5/9. Then black 2 means कितना 4 है, 4/8. Then red 1, that is 5/9. Red 2, that is equal to 4/8. It means नीचे 9 into 8, that is 12, 20, 20, 20. It means 60, 72/70. Here 72/72 means here 4 गुना 2, 4 into 3, that is 12, 4 into 5, that is equal to 20, 5 into 4, that is equal to 20, 5 into 4, that is equal to 20. That is 72/72. It means now take another question. Now, another question. 52 well shuffled cards are in a deck. You draw 3 cards. 3 cards one by one. First 2 cards are king and third card is the S. Then what is the probability of this? It means probability of a K K S. It means probability K1 intersection K2 intersection S3. It means in first draw that is the king mill, and the second draw that is the king, and third draw that is the S. It means the conditional or multiplication row king 1 into probability of a king 2 condition of a king 1, probability of S3, that is the condition of a king 1 into king 2. It means king, that is the 4 kings are there, so that's why 4/52. And second, after 1 king draw, then remaining total card is 51, then total king is 3. Another after draw, that is the 2 king, remaining 50 cards are there. Then what about S? S4 S is there, so that is 4/50. That is the 13, that is the 17, that is the 25. So it is a 2/13 into 17 into 25. This is answer. Now comes to independent event. Then what is independent event? Independent event. That means here condition is not affected. That is probability A condition B, that is equal to probability of A. Probability B condition of A, that is equal to probability of A. It means if probability of A intersection B is equal to probability of A into probability of B, then A and B are independent. Are independent. This is the funda. This is the funda. So if it is not equal to, then not independent. Now here, one example. Through a die once. Then what is the sample space? 1, 2, 3, 4, 5, 6. Event is given multiple of 3, that is equal to 3 and 6. F event is given, that is a even number, means 2, 4, 6. E intersection F is equal to, that is only 6. Now, probability of E intersection F is equal to 1 by 6. Probability of E is equal to 3 by 6, means 1 by 2. Then probability F is equal to 3 by 6, means 1 by, here probability of E is equal to 2 by 6. It is 1 by 3. Probability F is equal to 3 element, that's why 3 by 6, means 1 by 2. Here probability of E is equal to 1 by 2. Probability F is equal to 1 by 2. Now, probability E into F, probability of F, it means 1 by 3 into 1 by 2, which is equal to 1 by 6. Which is equal to 1 by 6. That is equal to, here, probability E intersection F is equal to probability of E into probability of F. So, E and F are independent. So, E and F are independent event. Now, take another example, which is independent. Draw a card from 52 cards. That is E is equal to, drawn card is the spade, F is the event, drawn card is the S. That means E intersection F, drawn card is the spade, as well as S. That means probability of E is equal to 13 by 52 means 1 by. Probability F is equal to 4 As is there. That is 4 by 52 means 1 by 30. Probability E intersection F is equal to, that is 1 by 52. Here probability of E into probability of F is equal to 1 by 4 into 1 by 30 is 1 by 52, which is equal to E and intersection F. So E and F are independent event, mutually exclusive. Mutually exclusive. It means A intersection B, that is I, then A and B are mutually exclusive. That means probability A intersection B is equal to 0. Then exhaustive event. Exhaustive event means if A union B is equal to sample space, then A and B are exhaustive events. Now, some proofs are there according to the independent event. This is very important for better to for, so that we need to do some question. So this is the some important concept which is given to this video. Now do some question. If A and B are independent events, then A and B dash are independent. A dash and B are independent. A dash and B dash are independent. Has to be. To prove probability of A intersection B dash is equal to probability of A into probability of B dash. Now, probability A intersection B dash is equal to probability of A, so B minus probability of A intersection. Now you check it. This is sample space. This is A. This is B. So A is the intersection with B, means B dash is what? B dash is what? This is B dash. Now, A intersection B dash, it means this is it. It means this is. So that it is A minus B, means probability of A minus probability A intersection B. So that probability of A into probability of A, probability A into probability of B, because here it is independent event. So probability of A taking common 1 minus probability of B, it means probability of A into probability B dash, which is RHS. So A and B dash are independent. Are independent. Now, second bit. Similarly, it is second bit. That is probability of B minus probability A intersection B. It means probability of B minus probability A into probability of B. Why? Now, A and B are independent event. Taking common probability of B, that is 1 minus probability of A, which is equal to probability of B into probability A dash, which is equal to RHS. So A dash and B are independent. Now we have to prove third concept. Third concept is given A dash and B dash are independent. A dash and B dash are independent. That means probability of A dash intersection B dash is equal to probability of A dash into probability of B dash. Now, LHS is equal to probability A dash intersection B dash. By De Morgan's law, it is probability A union B complement, which is equal to 1 minus probability A union B. That is equal to 1 minus probability of A plus a probability of a B minus probability A intersection B. It means 1 minus probability of A minus probability of a B plus, that is the independent, so that's a plus A into probability of a B. Here minus minus plus, this is independent, so this. Here it is a probability of A dash minus probability B taking common 1 minus probability of A, which is equal to probability A dash minus probability B into probability A dash, which is equal to probability A dash is equal to 1 minus probability B, 1 minus probability B. That means probability A dash into probability B dash. So A dash and B dash are independent. So A dash and B dash are independent. Now comes to one question. One such question is here also there. Probability of solving the problem independently by A and B are 1/2 and 1/3 respectively. Are 1/2 and 1/3 respectively. Means probability of A is equal to 1/2. Probability of B is equal to 1/3. Here independently A and B are solved, means A and B are independent event. So that's a probability A and B. Means probability of A into probability of B. It means 1/2 into 1/3, which is equal to 1/6. Now, question: if both are tried to solve the problem independently, find the probability that this problem is solved. Problem is solved means either A can solve the problem or B can solve the problem. So that's why it is A union. It means probability of A plus the probability of B minus probability of A intersection B. It means 1/2 plus 1/3 minus 1/6. So which is equal to 6 is the LCM, 3, 2, minus 1. Means 4/6, it is a 2/. Similarly, exactly one of them solve the problem. Means if A is solved, that time B not solved. Or means plus if B is solved, A is not solved. And means into or means addition in probability. It means probability of A minus probability of A intersection B plus probability B minus probability A intersection B. It means 1/2 minus 1/6 plus 1/3 minus 1/6. That is minus 1/6 minus 1/6. That is a 2/3. Now here the no cut, it comes to 1/2. The answer is 1/2. We know that neither A, suppose neither A nor B, it means A dash and B dash. Not or, that is the and. Not or. So that is the nor. So that is and. Similarly, you can do the problem easily. Now it is the independent. Then in the next part video, that in probability, we'll discuss in total probability theorem, Bayes theorem, and partitions, and also discuss about some random variables in probability distribution, which is in term 2. Thank you very much.